Hello everyone, and welcome to episode 2 of the Poke and Prod tutorial series. In the last episode, we saw what the finished project would look like and took a look at the project setup. In this video, we will be doing one thing: creating the player. If you remember from the completed game, the player can do three things. It can move in 4 directions, attack in those 4 directions, and interact with chests. Since we don't have chests yet, we will only be focusing on the first 2. Moving and attacking. Now, let's get started. Before we create the player, I'm going to disable the other components by clicking on each of them and clicking the check mark next to their name. This will disable the components until the next time we need them. Next, we're going to right-click in the hierarchy and go down to 2D Object and click Sprite. This creates a new object in the scene view, which we can start editing. First, I'm going to reset its position so that it is in the center of our scene, 0, 0, 0. Next, we can't really see anything since we don't have a sprite attached. So, we click the circle and type idle east 1, which we will use. Now we can see if we zoom close enough that it is covered by an icon. Let's move it to the side so we don't have that. I'm going to name this sprite Player. You can enter it in the field or by clicking Enter after it's selected. Now, we're going to add some components so we can add physics to our player. To do this, we're going to scroll down to Add Components and click it. The first thing we will add is a rigid body 2D and then a capsule collider 2D. Now, we will set the parameters for these components. Make sure dynamics is checked for rigid body and set the gravity scale to 0 so our sprite doesn't fall off the screen. We will also want to freeze the Z rotation so the sprite doesn't spin when it hits something. Next, we will set some values for the offset and size because our hitbox is a little bit big right now and we want it to match where we expect to get hit. I have some values saved already and set offset X to be 0.05 and offset Y to be -0.3, size X as 0.5, and size Y as 0.5. The collider may look a little bit low now, but that's because we want to give our sprite some depth, and this would be better represented by using the sprite's feet. Now that the player setup is done, go to the Scripts folder, right-click, then go to Create, and click on C# Script. We will name this script Player Controller. To edit the script, double-click it and Visual Studio should open up. The first thing we will do is erase the 2 functions we see here so we can start from scratch, and then create regions so we can better organize our code. The first region I'm going to create is movement variables. Then I'll create physics components, unity functions, and movement functions. In order to move the player, we're going to need some variables. The first one will be a public float called moveSpeed. We will make this variable public so we can edit it in the inspector in real time and try different speeds to see which we like the most. We're also going to need two floats called x input and y input, which we will see the importance of later. Inside the physics components region, we're going to access the components we place on our player. We do this by adding variables. The first variable we are going to add is rigid body 2D, which we will call player RB. RB standing for rigid body. This variable controls the forces we add to our player. Next, inside of the Unity functions region, we are going to create two built-in functions, awake and update, which you can use tab to autocomplete for you. Awake is called once when the object is created, and update is called once every frame. For practical purposes, that means we don't want anything heavy or costly in update, because it is called very frequently. If we do add something too big, it could lag the game, bug it, or crash it. Now, inside awake, we're going to want to access our rigid body and save it to player RB so we can access it more easily later on. To do this, we call player RB and set it equal to the getComponent function with type rigidBody2D. What the function does is it looks on whatever object the script is attached to and accesses the desired component type. For now, we're done with the awake function, and we'll come back to it later. In update, we need to do three things. First, we're going to want to access our user input values. User input referring to button presses or mouse clicks that will correspond to the player movement in the game. To see what buttons are set to which inputs, we need to go to our input manager, and to access this, we go back to our scene, go to Edit, and click Project Settings, and then Input Manager. You will notice multiple axes, but the only ones we're concerned with are horizontal and vertical. When you extend horizontal, you will see it has a negative button, a positive button, an alternative negative button, and an alternative positive button, as well as some other variables that we won't be using. What we will need to know is that the positive button is A and the negative button is D for the horizontal, while the positive button is W and the negative button is S for the vertical. If that sounds familiar, that's because we're going to be using WASD movement. Now, going back into the code, we're going to say that our X input is equal to getAccessRaw and the name inside the input manager. So for X, I type in horizontal. Then we will do the same for the Y input. Let's type Y input is equal to getAccessRaw and put vertical inside. So, since it updates every frame that we're pressing the WASD keys, it accesses it and sets it as a value between -1 and 1, corresponding to the respective directions. Now that we have that, we want to call a move function that we will create now. We will type private void move. This will move the player based on WASD inputs and the variable moveSpeed which we defined earlier. So far, so good. Since the X input and Y input are already declared in the scope here, we have access to them in the move function. So we can check to see which button is being held down and move based on that. So if our player is holding down the D key, we want them to go right. Now recall that D is associated with a positive value. This means that when the player is pressing D, the x-axis will return a 1, and when they hold down A, the x-axis will return a -1. We can use this inside of our if cases to detect which direction we want them to move by the integer value returned by the getAccess variable. So we will set up some if cases here to check each of the directions starting with the x-axis. So we say if our x input is greater than 0, which in our case can only be 1, they are moving to the right. Now in order to set a player's move velocity, we are going to type player RB dot velocity equals vector2 dot right times move speed. Now, we do the same for if the player is pressing A. If the x input is less than 0, our player rb.velocity will be equal to vector2.left times move speed. Now, what does it mean when we refer to vector2.right and vector2.left? Well, what it means when we refer to our velocities is that we are referring to our vectors. And if you're familiar with geometry or trig, vectors give you a direction and a magnitude. In our case, x input tells us our direction, right, which is positive, or left, which is negative, and in order to find the magnitude, we will be multiplying our direction by move speed. So, vector2.right is essentially a vector of 1, 0. And where 1 is on the x-axis and 0 is on the y. And for vector2.left, it would be -1, 0, with the same corresponding axes. In both cases, we have a direction and are scaling it by our magnitude, which is move speed. Now that we have finished the x-axis, we still have to handle the y-axis, and we can just copy and paste this section and change x input to y input, then change right to up and left to down. Now we have all inputs handled except for one, which is no input. So, if no button is pressed, we expect them to stand still. We will set that case to make the player's velocity equal to 0 if none of the buttons are being pressed. We can achieve this by using else if for all our cases, instead of using if. That way, if it passes through every one of the checks and fails to enter any of them, then we know that the player isn't moving. With this, in theory, everything should work. Save this and go back to Unity. We will then click on our player, and inside of our project files, we're going to find our script and drag that into the component section so that it applies to our game object. You should try to put in some value for speed. Now, it may be that the camera is not showing your player. To fix this, we will adjust the z-axis of the camera. First, you might want to turn off the script that is attached to it. We can think of the z-axis as the depth. So if it is too far forward, it won't pick up the sprite that is behind it. So to fix this problem, we will set our camera to be -3. You can make it less than -3, but -3 will do just fine. Now, we press play once, and when we see that it loads, when we press the WASD keys, we should be able to see that the sprite moves. You may notice that some of the keys override others, like up being overridden with left and right. This is because of the order that we wrote our if cases. This is not the best way to implement top-down movement, so feel free to improve upon it if you feel the need. Now that we have the fundamentals of movement down, we can handle attacking. In order to do this, we will need some attack variables. So I will add a region called attack variables. The first variable you will need is a public float damage, then a float for attack speed. In our case, attack speed is how long you need to wait before you can attack again. In order to keep track of this, we will also need a timer variable, so we will create an attack timer float. These two variables are going to work hand in hand. And our attack timer will either count up to 1 second or count down from 1 second. And once it has hit its final value, that's how we know we'll be able to attack again. Upon attacking, we will reset it and let it count down once more. In addition to these, we will need a public float for hitbox timing and for end animation timing. The reason we have these two variables is so that we can have a delay from the start of our animation to when we actually hit the enemy. This is so you don't hit the enemy when you're winding up, you hit when the sword is at the point of its attack. And so, we're going to have a variable that keeps track of how long it takes for the sword animation to reach its final point. In that instance, we're going to use a raycast to check who we've hit. That may sound pretty abstract right now, but we'll get there, and it'll make much more sense. On top of that, we need a check for if we are attacking, because we want to pause our movement in the case that we are. We will also need a vector 2 to keep track of our current direction. Our current direction is important, because when we attack to the right, we don't want the hitbox to be sent to the left. We will also need attack functions. So I'm going to create another region called attack functions. And so this one's slightly different and kind of counterintuitive, but we actually need two functions. The first one is going to be a private void attack, and this just attacks in the direction that the player is facing. The next one we need is kind of confusing, and is going to handle animations and hitboxes for the attack mechanisms. Instead of being public or private, this is going to be an IE numerator, and we're going to name it attack routine. This function is an example of a coroutine. Coroutines are going to be explained to you guys more in a later lab, and it's one of the more advanced topics, so you don't need to fully understand it right now. All you need to know is that it runs asynchronously, which means it runs at the same time as update and other coroutines. You may also need to know that it is very similar to 61A if you remember generators, yield functions, or yield statements. So just keep that in mind when we go over it more in the future. In the attack routine, the way we end it is by using yield return. We'll add more stuff to this later, but right now all we want to do is print something to actually make sure that we're calling this function correctly. So we'll type debug.log attacking now. Now we just have to call attack if we press the correct button. I'm going to use J as mine, so we type in input.getKeyDown of keycode.j. This line goes to the same input manager that we saw above, and instead of getting access to the key, you get access to a key that is pressed. This will be true in the exact frame where someone presses the J key, so it only occurs once every time you press the J key, and then if that happens, we're going to call attack. Let's go see if this works. So press save, and then press play when you're ready. Alright, start moving around and then press J. You should see in the bottom left it says attacking now, and if you click on this, it brings up your console. This is everything you've printed as well as some other warnings and errors that you might have. If you ever see a red exclamation mark down here, click on it, and it will be why your code isn't running. And if you double click on that, it can take you to the line that isn't working. This is really helpful when debugging. Now, if you spam click J, it should print attacking now every time you press it. We're going to implement the timer so we can't spam the attack all we want. Going back to the code, you'll remember that we have an attack speed and attack timer variables. Now in awake, we're going to set the attack timer to 0. In case it's anything else, we just want to reset it. Now, when we call attack, we want to check that the player is actually able to attack. Basically, if they've waited long enough. The way we check that is by checking that the attack timer is less than or equal to 0. Essentially, every time we call attack, we're going to set attack timer to some other number, and then it's going to count down from there. So if we're not attacking, we have to make sure that we're actually decreasing the timer. Attack timer is minus equal time.delta time. Time.delta time is a unity variable that keeps track of time in between frames, and essentially it's just a way of counting down or counting up depending on how you implement it. You will often use this to scale movement so that it's a lot smoother. We're just using it as a timer this time. And then we're going to go down to our attack function. In addition to attacking now, we're going to set the attack timer. Attack timer is equal to attack speed. So now every time we attack, we should set attack time to some number, and it'll count down until it's ready to attack. Go back to your Unity, click on the player, scroll down, and you should see some extra input fields. Let's set attack speed to some large number like 3, just for now. And then if you press play, you should be able to press J. It'll say attacking now. But if you spam J, it should only print it once every 3 seconds. That's how we check if our timer is working. Now that we know our timer is working, the next part is making sure we can actually attack in the correct direction. And the way we're going to do that is with current direction. This can only set our direction in when we're moving, and because it determines where we're facing. So we're going to go to our move function, and then if we're moving right, then we want to set our current direction as right, so vector2.right. If the player is pressing A, we're going to set it to left. If they're going up, we'll set it to up, and so on. Okay, and if they haven't done anything, then we're just going to remain facing the way we were previously facing. In addition to printing that we're attacking now, let's print out what direction we're attacking. So debug.log and current direction. So we expect if we're pressing A, then we press our attack button, we should print out -1, 0. That's because, as a vector, -1, 0 is pointing to the left. Let's make sure that's the case. Alright, and now let's test the other three directions. Up should correspond to 0, 1, right to 1, 0, and down to 0, -1. While we're at it, let's also fix the attack speed, so press play and we can edit this value. I'm going to set it to 0.5. Now that we've figured out direction, let's go towards casting our hitbox in the right direction. So our coroutine is going to be handling all hitboxes, and that is because in coroutines, you can do something really useful, which is you can write a statement that says yield return new, wait 4 seconds, and then something like 0.25. And this says that we're going to wait for 0.25 seconds before continuing to whatever code is below it. So in our case, this will be useful when timing our hitbox. So the first thing we're going to do is we're going to pause our character's movement for the duration of the attack. This is a design choice, so we'll just stick with it for now. To do that, we're going to set its attack to true, and we're going to set the velocity of our player to 0. So we want a brief pause before we calculate the hitbox, so this is where the yield return new wait 4 seconds goes. And instead of a fixed number, let's use a variable we defined earlier, hitbox timing. And below this, let's go ahead and for testing purposes, we'll add a debug.log casting hitbox now. This should go through the console as mentioned, and once we go through this code, it will let us know once we've hit that line by outputting this text. Now that we have our coroutine defined, let's go ahead and make sure it gets called. So inside our attack method, add a start coroutine and run the attack routine. We will also label this and comment that it handles all attack animations and calculates hitboxes. Now if we save the script and go back to Unity, let's find in the inspector our player and set a value for our hitbox timer, something like 1 second. Then when we hit play, we should move like before, and when we attack, after a second, you should see our debug.log hitbox cast now. This lets us know all of the logic in the code is working, and we can now finish implementing the hitbox. I'm just going to write up this line and then explain it as we go. So we'll first create an array of type raycastHit2d. We're going to call this hits, and we'll set this equal to physics2d.boxcastAll. Now you'll notice something as I hover over the parentheses. This dialog box pops up, and you can see it describes all the parameters this method can take in. There are multiple sets of parameters, and this is one of 5. So we're going to go to the second option, where it takes in an origin, a size, and a few other parameters that are important for our purposes. So, for our values, we'll say we want the origin of our hitbox to start where the player is, so player RP.position. But we don't want it to be on top, because his attack is coming from a certain direction, so we'll do plus cur direction. For our size, we'll do vector2.1. Then we'll do 0f, vector2.0, and 0. Now I'm going to explain what we're doing first. What is a box cast? Basically, we are projecting a box in front of wherever the player is facing and asking, does this box intersect with literally anything? It draws a box and returns anything it hits inside the box. So our inputs are the origin of the box, which is why we offset it from the actual player, and the size. So vector2.1 is a vector with 2 values, 1 and 1. So it's a 1x1 box we are casting. We won't be needing the other parameters, but for clarity, when we put in an f after an integer, it shows Unity that the number is a float and not just an integer. Now that we've stored everything that we've hit, we can iterate through them. So let's define a for each loop here. And notice how before I completed typing it, there is an autofill that pops up. And I can press double tap or click it and it will complete it. All I have to do is fill in the blanks. You can do this whenever you see an autofill dialog pop up. In our case, the variable type will be raycast hit 2D. Instead of item, we will have hit. And in our collection, we will have our list of hits. What are we going to do with these hits? Well, our original intention is to attack an enemy. So for now, we will categorize things in two camps, enemy and not enemy. Now, how can we derive that information from these hits? Fortunately for us, raycast hit 2D has a way for us to obtain the name of the game object that is being sorted in that hit. In order to get that, it is hit.transform.name. And for our debugging purposes, we will just put this in the console, so debug.log around that. We can, however, also get the name of the tag associated with the hit. So we can make an if statement, do hit.transform.compareTag, and say if this is the same as enemy, we can debug.log tons of damage. What this says is if our hit transform is equal to the tag enemy, we will print tons of damage. Now, what is a tag? A tag is a label you can assign to all of your various game objects, and they are useful for these kinds of coding purposes when you want to differentiate or specifically select objects with certain tags. So if we go back to Unity and click on our player at the very top of our inspector, you'll see that there is an attribute field called tag. You can click the field and get a drop-down, and you can see that it can be set to a number of things, whether untagged, editor only, main camera, or player. If you haven't selected the player tag already, do it now. Notice that there is also an enemy tag. Now, going back to the script, once we detect our hits, we're going to add another yield return new wait 4 seconds. And this is so we can wait for the animation to end before we allow our player to start moving again. So once we finish waiting, we'll set our is attacking to false. And the reason that we have this boolean is because otherwise the update function would be able to override our rb.velocity, which we set to 0 at the beginning of this coroutine. So inside of our update function, before all of our movement, let's set a new if case. We will say if is attacking is true, we're just going to return. That way, whenever this variable is set to true, we'll never take any of the player inputs. We will just be attacking until it's finished. Now, let's make sure all of our variables are declared. Then we'll save our script and go back to the editor to fill out some of the values in our inspector. We will keep move speed as is, set our damage to 2, set our attack speed as 0.5, hitbox timing as 0.1, and end animation at 0.1. Now, let's hit play. We should still be able to walk, and when we attack, you will notice that we still stand still for a fraction of a second. Now that all that is done, we will start making the character animations. To start, we're going to go to Animations, Player, then right-click and go to Create Animator Controller, and name this Player. If you double-click Player, it should open up this tab over here. So a little bit about this tab. The animator is a state machine, so you can create states by right-clicking and then selecting Create State, or either empty or from a new blend tree. You can make transitions between states, but this just allows you to transition between different animations by clicking buttons and other stuff. Now, what we're going to do first is create some parameters. And these are going to be used for transitions. So we'll create a float called dir x and another float called dir y. And just a reminder, but when you create animator variables, you have to make sure you spell them exactly the same. So capitalization is important. We are also going to need a boolean for moving and then a trigger for attack. Now that we've created parameters, let's create some states. And so we're going to create a state. We're going to go to form new blend tree, and you see where it says blend tree and has like a little orange. Click on that. We're going to change the name to idle. We're going to make another blend tree and name it move. And last, we're going to create a new blend tree and we're going to call it attack. Now I'm just going to arrange these in a way that I like it. Okay, now a little bit about animators. You'll notice there's an entry over here. If you hold Alt while clicking and dragging your mouse, you can navigate to it. On entry, there's an arrow pointing to idle. That means that whenever you start your game, this is the state and the animation that it plays automatically. You can change this to whatever you want. Idle makes the most sense because our player will not move or attack at the start. Okay, so now from each state you can create transitions, so you can right-click on idle, make a transition, drag it to move, and do the same thing from move to idle. And then from any state, you're going to make a transition to attack. And from attack, you can create a transition to idle, and then a transition to move. So now what we have to figure out exactly is what causes these transitions. So from idle to move, it makes sense that we're going to have a boolean that's checking if our player is moving. And if that's true, we're going to transition. So click on the arrow, going to from idle to move, and go to conditions. It says list is empty, so click the plus button, and you'll see that there is a drop down, and then a field, and then a value. So we're going to click moving. Now we're going to set it to true. This makes sense. If you're moving, you should be in the move state. The other thing we're going to do is we're going to get the exit time and uncheck that. I'm going to click settings, then we're going to click fixed duration. And we're going to do the same thing for the arrow for moving to idle. And now we're going to do if moving is false, and we'll go to idle. Now let's handle the transition from any state to attack. Any state is just a way of reducing the number of arrows that we'll need. So any state says if you're currently in a state and want to transition to attack, you just do it. You don't need to draw an arrow from, say, idle to attack, as long as you have an arrow from any state to attack. Okay, so let's figure out how we transition to attack. Here we will have a trigger. A trigger is basically like a button. So if you click the button, it activates, and then it resets itself. Okay, so for any state, go to Conditions, Attack, and that's all you need. A trigger is like an instantaneous thing, so we don't actually need to check it because it's not a boolean. Cool. And then attack to idle, we're going to click that one, and then we're going to conditions are if moving is false. And then this next one's slightly different. We want to have an exit time for this animation, just so it looks cleaner. So we're going to leave extra time. We're going to click not fixed duration. Then you set exit time to 0.5. These are just values that I worked out on my own. I'm going to do the same for move, so we're going to set this is moving to true. We're going to set fixed duration and set the exit time for 0.5. and that should be good. Now we have all our transitions set. We have move to idle, idle to move, attack to idle, and then anything to attack. So where exactly do we set these parameters? We will be setting these parameters in code, so we can move to that now. Before we start setting any parameters, we have to access the animator itself, so we're going to create another region, and this is going to be called animation components. I'm going to end region, and then in animator, I'm just going to name an animator anim. Okay, we need to access this in Awake, just like how we did for Rigid Body 2D. We're going to do anim, get component of type animator. Now that we have this, we can set any variables relating to the animator. The first thing we're going to have to handle is if we're actually moving. So we're going to do that in move, which makes the most sense. So I move at start. You're going to access the animator, and so as our variable, you want to say set bool. It takes an integer ID, or a string value. I always use string because it makes the most sense to me. And so this is the string that you're going to access. You have to make sure your capitalization is correct. I'm going to type moving, and the value is true. The only other case is that it's false, and that's covered here. So we're going to add an actual line here and say that set bool moving false. That should handle our transition between moving being true and false. The next thing we have to do is check if we're attacking. So we're going to go to attack functions, and more specifically, we're going to go to our coroutine. Now after this line we have here, where we freeze the player, is where we have to start the animation. How you do that is you go to anim.setTrigger, and then the string name, attack. So we're going to save that, and if you go back to the animator, you'll notice that we haven't touched dir x and dir y yet. So we have 3 states currently, but 12 animations. We have 4 idle animations, 4 move directions, and we have 4 attack animations. So how do we handle that? The first thing we're going to do is we're going to double click on idle. You'll notice this takes you to a brand new area. This is a blend tree. It should be blank except for one little thing in the middle. If you don't know how to get out, the way you get back is you click on base layer. Clicking on that twice should take you back. Now we're going to title this blend tree idle. We're going to go to blend type, and we're going to do 2D simple directional. And then we're going to set the parameters. So the animation that's going to be selected is dependent on these 2 parameters. This is your horizontal facing direction and vertical facing direction. So let's set that to dir y. Cool. Now we talked about having 4 idle animations. So we're going to create 4 motions. For this, add a motion field, and then add another, and one last one. Alright, so you notice that they created this weird field up here. This will make more sense when we actually start adding animations. Let's set this up first. So I'm going to put in idle north, idle south, idle east, and idle west. These motions are animations, and these are going to be played based on these values. North is only going to be played when y is 1 and x is 0, or in this general direction. If you hit enter, you'll see a little diamond got moved to up here. For south, we're going to do the same thing, except it's going to be -1. For idle east, it's going to be +1 in the x and 0 in the y, and idle west is going to be the same as idle east, but with a -1. See, now that's created almost this sort of cross. So if we go to our blend tree over here, and we actually select the values that are passed in for dir x and dir y, you notice that by dragging it back and forth, this red dot moves. And so whichever one the dot is closest to is the animation that will play. So say dir x is 1, which means we're pressing the right key, so it's closest to the right one. So it plays idle east. On the left, it goes to idle west, and at 0, 0, it shouldn't play anything. We want to do this for each type of animation. So let's go back to the base layer, go to move, and let's repeat what we've done before. We're going to blend type, then we're going to change the name to move. We're going to do simple directional 2D. We're going to add the parameters. We're going to add 4 motion fields. We're going to do walk north, walk south, walk east, and walk west. And then we're going to set the values the same as the last time. One, -1, 1, -1. And you can test it out for yourself again to make sure it works. And if you make sure these are correct, we can go back to the base layer and do it one last time for attack. Now that we've set up all 3 blend trees, we can go back and actually set the variables to our code. So let's go back to player controller and set animator values. Animator values for moving and direction are handled in the move function, so that's where we're going to go. We set the animator values by doing anim.setFloat, because float value variable is dir x and dir y. Don't forget to capitalize. We're going to do curDirection.x, so current direction is currently a vector 2, which means it has an x component and a y component. We can get each component separately if we want. And then we're going to do dot set float dir y curDirection.y. Alright, let's go back and see if this works. Before we do that, let's go back to player. We're going to drag this animator onto the player and drop it. So you notice that creates a new component, with the controller being the player. Save the game. Now, when you move the player, it should work. So when we move them back and forth, if you can't see, feel free to maximize on play, or just look at the scene view. You can zoom out a little bit. If you go back and forth, you're moving. If you actually did move, you're idle, and then if you press J, it attacks. So that's the animator. That is the end of the tutorial video, and next time you should be working on the enemy, which should go by a bit quicker than this episode. That's all. Thanks for tuning in. See you next time.